Alright, so here's the worked out key for the Unit 6 review. First of all, there's a small typo on number 1. The plus right here should actually be a minus. So this should be a minus. Right, this is a difference of perfect cubes. So the cube root of 27 would be 3x, and the cube root here would be 1. So remember, perfect cubes makes a binomial and a trinomial. My binomial is created by my factors, 3x minus 1. My trinomial is created using SOFAs. Remember a little shortcut? So we square the first term, giving us 9x squared. The opposite is plus. We multiply the two factors together, giving us 3x. We add, and then we square the last term, so 1 squared is 1. Then for the denominator, it was already factored for us, so it saved us some time. This cancels, leaving with just this is my answer. And you can check, because it is a trinomial, you want to check and see. We know this trinomial is going to factor into a set of binomials. So we're going to see if we can get it to factor. Numbers that would multiply to give you 9 and add to give you 3. Well, the only factors are 1 and 9 and 3 and 3. And neither of them will make 3. So it won't factor. All right, number 2. Oh, as for restrictions on this one, I'll just do restrictions for the first couple. But this restriction, you look here, x could not be 4. And on this one, it would be 1/3. Remember, if you don't know how to find the restriction, that's where you set it equal to 0. For example, this problem right here, I would set it equal to 0. Move the 1 over and divide by 3. So x can't be 1/3. On this problem, okay, we're going to factor. Some of you still have trouble factoring with the leading coefficient. So remember, that's where you have to do numbers that multiply to give you -6 and add to give you 5. You got to be careful, because to get 6, I could use 2 and 3 and 1 and 6. So if I try 1 and 6, I want to add to give me 5. So if I make this, let's check and see if it works. -1 times 6 is -6. -1 plus 6 is 5. So I'm good. But that's not my answer. Remember, I have to take this and split it. So one of my factors is 2x minus 1, and the other one, this reduces, x plus 3. Now for the denominator, it's not quite in the right order. So if you rewrote this as -2x plus 1, it is very close to this one. You'll notice that this is an opposite sign and this is opposite sign, right? So if I just take a negative out, see what happens? This cancels, leaving me with x plus 3 over -1, or you could write it as -x minus 3. As for my restrictions, it would be 1/2. X cannot be 1/2. And look right here. Move the 1 over and divide by 2. Number 3. Number 3, this is a binomial. I can take a 2 out, giving me y squared minus 25. And now you'll notice that it's actually a difference of perfect squares. So 2 times y plus 5 and y minus 5. So we got that going for us. Now let's factor this. Again, it has a leading coefficient. So numbers that multiply to give me -20 and add to give me -8. 1 and 20 won't give me 8. 2 and 10 will. And you want them to add to give you a -8. So that's going to, now then don't forget to divide by your 2y. And what you're going to notice here is that both of these cancel. And when I do that, okay, we've talked about before, right? That would mean that my answer is y plus 1 and y minus 5. But if you check it, it doesn't work, okay? And remember us talking about when we had our factoring unit before, if they both cancel, odds are you probably could have taken out a GCF. Right? If you look, what could I have taken out of all of them? A 2, right? So the GCF that we should have taken out, which we factored, is 2. So 2 times y plus 1 times y minus 5 And let's check it. Negative 5, 1, and 2 make negative 10. Yes. Y, and 2 make 2y squared. You could have also just taken the 2 out and then factored. So the 2 belongs here, and then this factored is these. These cancel, and the 2's cancel. So you have y plus 5 over y plus 1. Y would not be able to be negative 1 or 5. Number 4, if we want to change the order up a little, okay, we have negative x squared plus x, which I'm going to take out a negative x. So it leaves with a negative. Sometimes it's just better. So you get x minus 1. And then on the bottom, we can factor this. There's no leading coefficient, so it's easy. You just want numbers that multiply to give you negative 2. It's going to be a positive 2 and a negative 1. These cancel. X could not be a 1 and a negative 2. All right, let's move on. This is a multiplication problem. And in this problem, guys, you have to keep them neat or you'll end up forgetting numbers. So I'm going to try to cancel as little as possible. Remember, when you do cancel, you keep one has to be in the numerator and one has to be in the denominator. I think all I'm going to do is just 1 right here. I'm going to make this go away and factor it with this to give me 2xy squared. And I'm going to stop there. Okay, so that gives me 8. Let's count my x's. 6 and 2. I'm going to cross them off so I don't forget any. Giving me 8. 3 y's and another y gives me 4. 4, 5, 6, and 7 z's. Got to be super careful so you don't make a mistake. On here, the 2 and the 3 give me a 6. I've got 1, 2, 3 x's, 4 y's, and a z. Now let's cancel what we can. Our 8 and our 6 reduce to 4/3. For my x's, I'll have 5 in the numerator, and y's cancel all the way. And for my z's, I'm going to have 6 in the numerator. And there you go. Number 6, you have to have a common denominator to add. It's an addition problem. So in order to find one of the easiest ways to always factor the denominators, so this becomes x plus 3 times x minus 4. If something doesn't ever work out quite right or it looks funny, go back and check your factors. That's the biggest mistake kids make. Let's check. Yes, negative 12 and x squared. You always want to check to make sure you factored it right. So my common denominator would need an x plus 3 and an x minus 4. The first fraction has both, so you're just going to move your 3x over. And my second fraction, in order for the denominator to look like this, I had to multiply it by x minus 4. So I have to do the same in the numerator. The other mistake kids were making a lot is they're forgetting to apply it to both. So plus 2x minus 8. Okay, then you clean up the top and see if you can factor. So this becomes 5x minus 8. And then x plus 3 and x minus 4. And you can't go any farther, so you're done. Number 7. On 7, again, it's an addition, and I see subtraction. So I'm going to go ahead and take care of that right now so I don't forget it. All right? And in order to get a common denominator, we have to look at the denominators and factor them. It makes it easier. So this is going to be x plus 4, x minus 4. My denominator then, this first fraction has an x plus 4 and an x minus 4. This one has x minus and it says x plus. Right, so the first one needs nothing. I'm going to slide it over. The second fraction needs an x plus 4. Don't forget to distribute to both. So plus 3x plus 12. This needs an x minus 4. Again, both. So negative 5x plus 20. Combine like terms to clean up the top. 10x, 3x, and negative 5x gives us 8x. And 12 and 20 give us 32. You'll notice that 8 fits into both of these. You can't box your answer till you look and see if you can factor and cancel a little bit. Okay, and I can take an 8 out of here. So the x plus 4 is canceled, giving me with x minus 4 in the denominator. Right, number 8 is another subtraction problem. Turn to addition, move it over. Get your common denominator, x plus 5 and an x minus 2. Compare. First fraction needs an x minus 2. Don't forget both. So 7x minus 14. This needs an x plus 5. Watch out, that's negative. So you get negative 3x minus 15. Lots of points lost on the quiz for not watching that negative. 7x and negative 3x make 4x, and this becomes negative 29 over x plus 5 and an x minus 2. Before I box it, check and see if I can cancel or reduce or anything. This does not reduce, so you're just done. Okay, the last couple we've done was addition, so you had to get a common denominator. We're back to multiplication. So you don't need a common denominator, you're just going to factor and cancel. If you look at the numerator here, you can take out an 8x squared, giving you x squared minus 4, which can be factored again. So you're going to have 8x squared, x plus 2x minus 2, over 2x to the 5th times 3x squared over x minus 2. This cancels. Okay, and you can decide what you want to do here. It gets kind of messy, so I'm just going to go ahead and write 24 and have 4 x's and my x plus 2 over 2x to the 5th. This becomes 12. This leaves me an x in the denominator and x plus 2 in the numerator. Number 10 is a complex fraction, guys. All it's saying is to take this fraction, divide, so I'm going to make it to multiply, and flip this. That's all that it is. Okay? It's saying a fraction divided by a fraction. So change division to times and flip the bottom fraction. Now then you have to factor everything. So if we factor the top, we're going to get x minus 4 times x plus 2. Here is a perfect square trinomial, x plus 4 times x plus 4. The numerator gives me x minus 1 times x plus 4. And this was already factored. Just cancel what you can. I'm going to live with 2 in the top, 2 packages in the top, and 1 in the bottom. All right, number 11. Number 11 is an addition problem, so you have to get a common denominator. Before you can do that, you have to factor it again. We're going to get really good at factoring by the time you're finished with this unit. Alright, when you take a look at this, okay, this needs a negative 5 and negative 3. This is a negative 3 and negative 6. So the denominator is actually going to have 3 different parts. It's going to have an x minus 5, an x minus 3, and an x minus 6. Okay, and guys, remember again, when you go wrong, if something doesn't look right, go back and make sure your signs are correct. Negative 5 and negative 3 make positive 15. Negative 5 and negative 3 make negative 8. I'm good. Negative 3 and negative 6 make positive 18. Negative 3 and negative 6 make negative 9. You just want to be sure you didn't miss a sign. So that means this needs an x minus 6. Be careful because it's negative. So negative 2x plus 12. This side needs an x minus 5, giving me x squared minus 5x. So when I clean up the top, I have x squared negative 7x plus 12 divided by x minus 5, x minus 3, x minus 6. Okay, this is a trinomial. If I factor it, I'm going to get binomial, so it might reduce with this. So check, and it does factor to give you x minus 4 and x minus 3. So the minus 3's cancel. So your final answer is just x minus 4 over x minus 5 times x minus 6. Number 12. It's subtraction. Be careful. Alright? You need a common denominator when you add and subtract. So you have 6x minus 1 and 2x plus 3. Okay, so if I compare, the first fraction needs a 2x plus 3. Both, so you're going to have 6x squared plus 9x. This fraction needs a 6x minus 1. Careful with the negative. So minus 30x squared minus 5x. Compare like terms, or I'm sorry, combine like terms. So this gives me negative 24x squared plus 4x. No, plus 14. Guys, I'm sorry. This negative 5x, negative 1 makes positive. It's a positive 5x. I apologize. Now then, look at your numerator. Okay, before I box your answer, you check it. Can I take anything out? Absolutely. I can take out a 2x, and it leads with a negative. So I'm going to take out a negative 2x, giving me 12x minus 7. Okay, did that help me in any way? Does this 2x cancel with this 2x? No. Okay, this is addition, so it won't work. So factoring, it didn't help. So I'm just going to box this answer so I don't make a mistake in my factoring. All right, 13. We're just going to cancel. This is division, so you have to be careful. So on the top one, we can factor out an AB, giving me A minus B. That's this. You guys still, some of you have trouble factoring this, but look, if you have an A squared in the front and a B squared in the, if you have a set of binomials, to get A squared, you would do A and A. How would you get B squared? B and B. And if you check them, you can. So it's going to give you A squared plus 2AB plus B squared. So you're good. Now flip this. Don't forget to flip it because of the division. And the last one you don't have to flip. And then just cancel. A minus B cancels with this A minus B. Now be careful here. These cancel, okay? But you're going to have an extra B in the denominator. So your final answer is just 1 over B times A plus B. Number 14. Okay, this was an easy one. I already have a common denominator. It's a subtraction problem, so you have to have a common denominator, but it already has one. All you have to be careful of is the subtraction. So if you distribute it, you have 3x minus 5, because I'm just going to push it over because it has a common denominator already. Negative 7x minus 8. Combined like terms, so you have negative 4x minus 13 over x minus 3. Nothing cancels in the numerator. You can't factor it, nothing, so you're just done. 15. Right, again, a leading coefficient. Some of you struggle with this. So if you have a leading coefficient, you want numbers that are going to multiply to give you negative 12 and add to give you negative 1. The numbers that work are 4 and 3, and this is going to be a negative. Now divide it back by your 2b. So your factors then are just 2b plus 3, that came from here. This reduces, and b minus 2. The bottom is easier. It's just b plus 4 and b minus 3. Again, another one with a leading coefficient. Numbers that multiply to give you 9, add to give you negative 10. So you're going to have negative 1 and 9. Don't forget to put them over 3b. So this becomes 3b minus 1. This reduces, and b plus 3. Factor the top. It's just going to give us b plus 4 and b minus 2. Cancel what you can. The b minus 3, oh, I see my mistake. I'm sorry, guys. This should be a minus. I wrote it here. They're both negative. That's what I was saying. If it looks funny, check your factors. Okay, negative 3 and negative 1 should be positive 3. I'm good. And 3b and b should be 3b squared. If it looks wrong, check your signs. And then the other one that's going to cancel are the b minus 2's. So in the top, I actually have 2 factors still left. That's okay. On the bottom, I have b plus 4 twice. And you can just write it as a square if you want, or you can write it out 2 times. Number 16. It's a division problem. Don't forget that you're going to have to flip this. So I'm going to rewrite this and rewrite it as that factor. So negative x plus 5. This is going to factor into x plus 2 times 3x minus 1. Change division times, flip it. When you factor the denominator, you're going to get x plus 2 times 2x minus 1. And you can check it. 2 times negative 1 is negative 2. 2x times x is 2x squared. You're okay. Factor this to give you x plus 1, x minus 5. Now then, to check your to check your numbers here that cancel. This cancels here. This almost cancels, right? Opposite sign, opposite sign. So if I change this to be negative 1 times x minus 5, it will cancel. Right? Remember, they're just exactly opposite, so they cancel with giving me a negative. So you have negative 2x minus 1 on top, and 3x minus 1 times x plus 1 on bottom. And you can distribute the negative in the top if you would like, or leave it like that. 17. Alright, 17 is another perfect cube. Alright, remember when you factor, you're going to get a binomial and a trinomial. The cube root is y, and the cube root here is 5. So your first one's just y plus 5. And this is your sofas, right? Square the first term, y squared. Opposite means minus. The 2 factors together, 5y, add, and square the second. Now then factor this to give you y plus 9 and y minus 4. And you can check it. 9 times 4 is negative 36, and that's going to give you positive 9. You're going to multiply by, you don't have to flip it, and you don't need a common denominator. You're just going to cancel. Factor and cancel. Leaving us with y squared minus 5y plus 25 over y plus 9. You can check to see if you can factor this, but to get 25 you would use 5 and 5 and 1 and 25, and nothing will give you that, so you can't. It didn't help you. Alright, 18. Okay, remember on 18 there's 4 terms here, so you're going to factor by grouping. Right, and if you do that, you can take an x squared. An x cubed and x squared means an x squared out, giving me x plus 1. Kids struggle with that, but if you think about it, x cubed divided by x squared is x squared divided by x is 1. And you can multiply it out and check. X squared times x is x cubed, x squared times 1 is x squared. Now then, you're going to take, it leads with a negative, so take out a negative 1, giving you x plus 1. Change the sign of both. On the bottom, it's almost the same. Oh, I'm sorry. In fact, I forgot to tell you there's a little star on this one. This problem also needs to be changed. You need to put a plus right here. I apologize for that. Right, now then, factor an x squared out of here to give you x minus 1, right? This leads with a negative, so I'm going to take a negative out. So I want the opposite of this and the opposite of that. In the numerator, then, I want x squared times x plus 1 and negative 1 times x plus 1. So the way we write that is here. Right? Think about it. X squared times both and negative 1 times both. Same here. X squared minus 1 times x minus 1. These cancel, and you're just left with x plus 1 over x minus 1. These do not cancel again. Lots of you are still doing that. This is an addition and an addition, so it just stays the way it is. 19. Okay, we're almost finished, guys. This is a complex fraction, right? So if you think about it, remember, if you have something like 1/2 divided by 1/3, a fraction on the top and a fraction on the bottom, you just flip this to become 3/1. Okay, well, you can't flip this yet because there's actually something, you've got to clean this up first, right? You've got to find a common denominator, clean it up, then flip it. So if we take care of that, a 3 and a 2, my common denominator is 6. That means this needs a 2, and this needs a 3. Now you can flip it. You have a fraction in the top and a fraction in the bottom. So if I flip that, but this x and this x do not cancel, right? If all 3 of these, this x, this, and this had an x, yes, but it doesn't. The only thing that cancels is the 4 and the 6, leaving with a 2 and a 3. So you have 3x on top, and 2 times 2 plus 3x, which would be 3x over 4 plus 6x. Again, if there were an x in all 3, it would cancel, but there's not. This doesn't cancel either. Some of y'all want to make this 2x down here. No, this is finished just like it is. Number 20. Again, complex fraction. You want one fraction in the top and one in the bottom. So the bottom is good. We've got to work on the top. Common denominator will be an x minus 1 and an x plus 2. This side needs an x plus 2, so you have 3x plus 6. This needs an x minus 1, so you have 3x minus 3. If I was going to clean that up, I get 6x plus 3 over both of these. Right? All over this 3 over x plus 2. One fraction in the top, one fraction in the bottom, so let's flip. So the first fraction stays the way it is. Change this division bar to times and flip this fraction. The x plus 2 cancels. Okay, so on top I have 6x plus 3, and on bottom I've got 3x minus 3, right? I've got a 3, or another way to think of it is I've got a 3 times x minus 3, 1. So if you clean that up, you have this. Okay, now this does not cancel, right? But what does happen is each of these, I could take a 3 out, right? So I can reduce it, can't I? So you end up with, if you take a 3 out of here, you get 2x plus 1 over x minus 1. And you are all done. Good luck on studying, and we'll see you tomorrow for your test.